But before starting, let's try to do a quick recap if you're not familiar with serverless. First of all, what is serverless? Is an offering that we have in AWS that basically we are going to take care about the infrastructure for you. That doesn't mean you don't have to do anything. Obviously, you are also responsible for the code and the security that you're writing and all the wirings that you are activating in our services. But in reality, the scalability of our solution and the scalability of your solution and the way how you are, let's say, plugging everything together is managed by us. And the cool thing is that you can focus on what really matters, because we are here for creating value for our customers, and therefore it's very important that we think about that when we are deciding which kind of service what we want to use and specifically why we want to use them. The other thing that is interesting for serverless is that you pay for what you use. And therefore, you are not over provisioning your infrastructure, and you are going to pay for what exactly your API requests are, or the usage of how many messages you have inside a stream or a bus. So overall, as you can see, the model is shifted a little bit on the economical side. And last but not least, we are designing our infrastructure with best practices in mind. So the moment that you are, for instance, using a Lambda function over a container, you don't have to take care about the networking part unless you really want to work inside the VPC. But we take care about distributing your Lambda function in multiple AZ for multiple availability zone for your region. And we also take care about the security part. So we guarantee you that your workload is running inside a secure sandbox that is, let's say, guaranteed to run only your code for a certain period of time. So as you can see, there is a lot of work that we are abstracting from you using serverless, and we allow you to focus on what really is the key differentiator for your business. Now, when we think about serverless in general, we need to think about a more, let's say, operational model that is different from any other service. So, as you know, probably you can obviously run your workloads from on-premise or using virtual machine. You can use containers, and you can decide to go up to a more further abstraction to Lambda functions, for instance, when we talk about compute. But the cool thing of this is that based on your needs, based on the characteristics of your architecture, you will be able to select the right tool for the job. So for instance, if you have a very sensitive workload that requires to have full control on your database, you may want to use an EC2 machine for running your database with all the tweaks and things that are relevant for your workload. But at the same time, you might have a workload that doesn't need to have all this attention because it's I don't know, a cache. And in that case, you can use another service that maybe is more managed with AWS. So for me, it's very important that when we take a decision on how to design our solution, that we think about the wide spectrum of what is available in AWS. It's not just one solution that fits them all. We need to find the right tool for the job. So if we deep dive in the compute part, we have multiple offers, and we categorize in Amazon EC2, ECS AKS for container management, Fargate for serverless container management, and finally Lambda functions. So as you can see, in every single layer, you have the possibility to, you have some responsibility to manage certain things, and others are managed by us. And more you go towards the top of this diagram, towards the Lambda in this case, you have less responsibility on the infrastructure part, and you can focus more on the key differentiator. And it's obvious that vast majority of the time, you might want, especially if you work in large organizations, you might want to pick, let's say, the right tool for the job once again. So you might want to have some workloads that are using EC2 in conjunction with Lambda, and some other workloads that maybe are using containers in conjunction with the Lambda functions. So again, it's not let's say a religion word, but more is you need to pick the right tool for the job. It's more, it's never containers versus Lambda, but it's more containers and Lambda together for example. So when we talk about serverless, it's not only a compute service. At the beginning, obviously, less of them, but today we have, as you can see, a variety of them. We start from compute and data stores, talking about AWS Lambda, AWS Fargate, and we can go in the database side with Amazon Aurora serverless. We can go with DynamoDB, and also we talk about application integration. Therefore, that layer that is creating the glue between services, and in this case, in a serverless fashion, API gateway for exposing your API towards clients, or step function for orchestrating your workload and synchronizing multiple parts of your system, even bridge for creating the choreography pattern that is well known in distributed systems, and so on and so forth. We have another layer for developer tools, and in developer tools we move from infrastructure as code with CloudFormation to distributed tracing with X-Ray. So as you can see, there is a variety of tools that are supporting serverless applications and are not only for, let's say, containers or a virtual machine, but we can reuse the same knowledge that we have gained during the years for embracing also serverless. Now, I wanted really to add a couple of key points when we are designing serverless application before we deep dive into the patterns, because patterns might change, services are evolving every day, and we can substitute one over another one. But there are some key considerations that we need to think about when we are designing our serverless applications. The first one for me that is been a while I'm thinking about that is the concept of modularity. Is for me the key characteristics that is representing a North Star to follow when we are designing a workload nowadays. And that can be achieved in several ways if you think about that. It's not only through distributed architecture that you can reach modularity, but if you have disciplined developers, you can reach modularity also on your code base. It's important for me to highlight that when we think about modularity, we need to decouple a bit the implementation part from the architectural thinking. Because modularity, for instance, if we think about a microservice as a portion of a system, then it can be expressed in different ways and can be expressed with, for instance, a container, where in the container we delegate to the developers to maintain different APIs and controllers and everything, and the discipline of developers that are creating a modular code that will allow them to evolve quickly. Or you can delegate the same thing to a Lambda function, where the modularity is shifting from maintaining and based on let's say the API on top of web framework to instead infrastructure and creating the glue on multiple things. So every team is responsible for multiple one or multiple Lambda functions, and that will allow them to represent a bounded context or a microservice in this case. So again, modularity is something that I believe we need to think through properly. The second thing that you gain when you design serverless application is that you need to be comfortable with eventual consistency, because in reality, I learned the hard way, and probably many of you as well, that when you are designing applications, you don't need everything to be synchronous and transactional. You can embrace eventual consistency. Maybe you have a system that is running on-prem or is a third-party system that doesn't need to be updated real time. And that is a great way, because eventual consistency, when embraced correctly in distributed systems, allows you to reduce the cost of your infrastructure and make your operation way easier. And we are going to see that very often in the patterns that I'm going to show. The other thing that I exhort you to think about is architectural characteristics. You don't know how often I've heard a discussion where developers jump straight into the implementation phase, but they don't have clarity on what we are optimizing for. Architectural characteristics that are the ones that are ending, all the words that are ending with ilities or non-functional requirements, if you're familiar with the term, allows you to define what you're optimizing for. And that is key, because the decision to use the service or another one is based on that. The other thing that is important to Sorry, who is on call? Who is speaking?
Please
Can
mute
you go mute?
Alexander.
Bueno,
Alexander,
tendría
please
que revisarlo
mute
en
yourself.
interno, ¿no? Porque yo creería si hay tema de
Alexander,
problemas de comunicación. Sí.
let me mute yourself. That's okay. Thank you. Can you remove your camera as well, Alexander? Thank you.
Then the last one is traffic patterns. And traffic pattern is key because it's very important that you understand and you have clarity on how they works. And you might not know because maybe it's a new workload that you're building from scratch that you don't expose to your let's say customers. But also business case can help you to design properly based if you don't have traffic patterns. So therefore, business case is important, asking the right question with your business counterpart to understand what are the trade-off that we can take, because in reality what when we design a solution is always based on trade-off, and we try to find the right solution that is optimized for the architecture characteristics that we have in mind. Last but not least, what we are going to see during this presentation is I'm going to touch on all these key pillars that you can find inside the well-architected framework. Well-architected framework is a collection of best practices that we, let's say, learn following our customer during the years, and we want to, let's say, use for designing properly our workloads, despite our serverless or containers or virtual machines. Now, one thing that you will notice in the slides that we don't have many suggestions on the sustainability part, not because we are lazy, but because embracing serverless, you are already taking your step forward towards a more sustainable workloads because you pay for what you use, and when your resources are in idle, are not, let's say, used by you anymore, and therefore, in this case, you are going to you don't have to over provision or use, let's say, scaling that is not needed in your case, but you just use what is needed for doing your job, and the rest will be used across different customers. Now, let's start with the first pattern. So the comparable REST. And I know that the REST API probably is the first pattern that you will try embracing serverless, and in this case, a Lambda function. And usually what you have here is a very simple approach that is composed by an API gateway, and then you have a Lambda function that is, let's say, trigger when there is a request to a specific API or multiple APIs, because you can handle multiple APIs in the same Lambda function. And then you have DynamoDB for storing your data. Very simple approach. So in this case, you can create like a CRUD workload very quickly without too much effort. But what you need to think about when you created a simple REST API is that on the operational level, you need to think about access logs that currently by default are not enabled in the API gateway. So that's the first thing that you should, let's say, activate when you are working a simple REST API. The other things is focusing on structure logs overall of the application, because the reality is we are talking about distributed systems. If you don't create the right governance on defining your logs, maybe using JSON that we provide a nice structure and defining what are the key elements that are composing your logs, then you must find some challenge. You will find some challenges when you are, I don't know, querying your logs in your favorite observability tool. And the reality is that those stuff can be done incrementally. You can start simple and then slowly but steady, let's say, changing this. But it's something that you need to think about that as soon as possible. The other thing is around custom metrics is that so far many customers, when they were using Lambda, they were trying to use the AWS SDK using a put metric API for CloudWatch. The problem is that metric is synchronous and therefore is basically stopping till there is the response from CloudWatch that everything is going fine. You can have now for a while, actually since 2019, if I remember well, EMF or embedded metric format. And with this way, you can send way more way more metrics, custom metrics from your Lambda functions to CloudWatch for then inspect later on directly from CloudWatch. And the cool thing is that it's completely asynchronous and is going to cost even less than synchronous APIs. So this will not prevent your code to be, let's say, to slow down because you are waiting for the response from CloudWatch. It will be an immediate response because it will be taken, and you can send also even in batches and send to CloudWatch very easily. The other thing is on the reliability side is that, yes, you can scale with serverless pretty well. And you can scale at API gateway level, you can scale with Lambda function, and even with DynamoDB. But at some point, you might want to discard certain requests that maybe are not legitimate. Imagine if you start to have a brute force attack where they're trying to, they are calling your APIs in a regular interval, and they're trying to understand if there is specific value that they can spoof directly from your application. If you start to introduce API key, you can then associate to that specific API key a limit or a bandwidth of requests per second. And that is great because, and also burst traffic that you can have. And that is great because the moment that you don't have the API key available in API gateway, you don't even pay for the compute because the request doesn't even arrive to the Lambda function. And definitely is, all this stuff is, let's say, some let's say, way that are pretty good for optimizing your simple API, as we discussed before. And then we want to move a little bit further. So now we don't want to have only API keys. We want also to integrate with maybe socials or with your Active Directory. And in this case, you can use Cognito. Cognito is a service that we use for the authorization part of your system, and will allow you. There is a native integration with the API gateway. The other interesting part that we need to think about that is how we can provide secrets to Lambda function. Definitely not environment variables. This is something that we recommend. It's definitely something that we usually suggest to use the service dedicated for secrets, that is AWS Secrets Manager. And that because provides a bunch of capabilities like the rotation of your keys that are happening in regular interval directly from Secrets Manager. So you don't have to think about that piece of governance that we know is fundamental, but often is overlooked because maybe we don't have time to think about that, or we forgot to activate it somehow. And in this case, a Lambda function can retrieve at runtime the secret that is needed for maybe, let's say, creating connection with a database. And that is something that definitely you can do, but maybe you don't need secrets. Maybe you need, let's say, some parameters that are needed for, let's say, working with your Lambda. In that case, you can, if you don't need the secrets, you can use parameter store. That is another way to integrate with Lambda. You can do either runtime or provisioning time. Provisioning time, there is a nice thing that many people I discovered recently, and I wasn't aware, I didn't know about that in your CloudFront, in your infrastructure as code, you can define basically the ID of a parameter, and automatically CloudFormation is going to resolve that, retrieving directly from parameter store the parameter that is injected inside the environment variable. Bear in mind that if you do that at provisioning time, that specific environment variable will be clear inside the AWS console. So when you go to your Lambda, you can see what environment variable was injected inside your Lambda function. So if it's nothing that you need that is secure or whatever, use parameter store. Otherwise, you can use Secrets Manager. The other thing that you need to think about performance is that, let's start with DynamoDB that we didn't touch much. So you might want to use for unpredicted, let's say, traffic, on-demand billing. And the difference between provision and on-demand is that in on-demand, it scales up to 40,000 read and write requests per unit in the case of DynamoDB. And that is usually great if it's maybe the first 6 months stuff, you want to understand the traffic pattern of your workload, or you have, let's say, some spikes that are unpredictable. In that case, you can switch to on demand. But if you have a very steady flow and you know exactly how often you're going to be requested, you can go with provision. You can save in some money in that case, because it's definitely cheaper than using the on-demand billing. So you need to find the right configuration for your DynamoDB. In the case of API gateway, the API gateway allows you to have, in the case of REST API, to have different approaches. You can have regional, you can have edge, and in this case we usually suggest to use edge in the case that you want to let's say propagate and cache your responses worldwide, leveraging CloudFront that is spin up by Amazon API Gateway by itself, and regional in the case that your API are consumed only inside your region, and in that case you don't need to have let's say an edge distribution. Potentially you can always have your CloudFront distribution that is pointed to API Gateway if you want, when you want. So bear in mind this option. Last but not least, cost. It's important that you find the right size of your Lambda, because with Lambda function, you can decide how much memory you're going to use. Now, memory is associated to a bunch of other, let's say, characteristics like virtual CPU, networking, and so on. So the moment that you set up I don't know, 128 megabyte for your Lambda, you know that you have a certain spec of your Lambda. If you go up, you might risk that your workload is even cheaper than using a lower lower size of memory, because in that case it's faster the response time, and also the performance of networking and the virtual CPU are more, and therefore you're going to probably have a cheaper execution. So in order to try and find the sweet spot for that, we have an open source tool called Lambda Power Tuning that was created back in the days by Alex Casalboni, but is available on GitHub. You can download and try. And what it does is basically try your logic and see which is the right sweet spot based on the different parameters that you can tweak for a Lambda function based on the code that is running inside Lambda. That is a great way for optimizing your cost with Lambda. Now, the next pattern is cherry pick, or the GraphQL API. So GraphQL is by now, I think, a well-known approach for designing API, where you have a single entry point for your clients. Then you can start to query this graph of information that are retrieved by different part of your system. And we have a solution, it's called AWS AppSync, that allows you to have a managed GraphQL API for inside AWS. AppSync has a bunch of features. We are going to see them. And for something very simple, you can, for instance, retrieving some data from DynamoDB. You can use, let's say, the Apache Velocity template or VTL for defining when there is a request to your graph, which is the table that you need, DynamoDB table that you need to find some data and return back to the client. The cool things of these approaches is really, really simple. With a bunch of lines of code, you have this integration done, and everything is managed, scalability and everything by us in this case. And the other benefit for the client in this case is that they can query different parts, but then obviously not all, let's say, the domain in the case of our application might be as easy as just retrieving some data from DynamoDB. So when you have some more complex logic, you need to start thinking differently. So when you want to query these graphs or getting some data out from your graph, you might want to have a bit of compute. So in this case, a Lambda function, because AppSync can integrate with multiple services natively from AWS. And in this case, you have Lambda function that is, let's say, maybe doing some computation and verifying some logic, retrieving some data, aggregating, whatever it is, for returning the response to the client. In this case, for instance, the get loyalty API for a hypothetical, let's say, application for flights reservation. Then we move to mutation, and mutation in GraphQL is everything that we want to change. And in this case, if you have very complex, let's say, implementation, you want to leverage, let's say, what are the native constructs in AWS, you can even use step functions. And step functions are coming into flavors, standard, and express. And if you want a synchronous execution of a step function, you can use an express synchronous execution. And in that case, you will be able to orchestrate and natively integrate with over 200 services with inside your step function. We think about step function like an orchestrator tool that is also a low-code tool. So you define your state machine and all the logic with all the complexity around, for instance, retry and how to handle errors. If you want to, let's say, segment the logic or create if-else inside your logic, you can do, because step function allows you to have some integration and some construct for doing so. But it's even moving further. With intrinsic functions, you can even, let's say, convert, for instance, a JSON to string or vice versa. So there are a bunch of capabilities that you don't have to write a line of code, because everything is sorted out for you. And you have even a visual tool for that I use very often when I try to understand what I want to build in my step function, how certain things are working, for directly in the console for, let's say, creating your step function, and that will generate the Amazon state language, that is the state language that is interpreted by step function service for, let's say, consuming different services. As I said before, in step functions, you have an integration over 200 services. That means you don't have to create a bit of compute, maybe a Lambda function for querying a database like Amazon DynamoDB. You can go straight with integration in the ASL, so inside the Amazon state language, and retrieve and get an item, or maybe doing a query to DynamoDB or whatever. The other option that you have for more simpler transaction, imagine, for instance, you want to do a simple authentication with AppSync that it is not available out of the box, as we are going to see later on. One thing that you can do, you have a pipeline resolver that is, let's say, you can add a bit of logic that is concatenating the call of multiple services. So, for instance, you can call a Lambda saying, okay, check this JWT token with all my custom logic for authentication, and if the user is authenticated, move to the next step and return back the response to the user. Otherwise, just return an error. So these kind of things are totally doable, and as you can see, you have different options based on the complexity of what you need to build. The other interesting part is that you can enforce authorization at the API level, but not only the API level like you would do with the API gateway with REST, but also at the field level. And that's very interesting, because that means you can really create a level of granularity that you wasn't able before with REST. And this is, in my opinion, one of the key features that if you really need that, to leverage with AppSync. So, for instance, if you are an admin, you want to see a different response because you're asking for different fields. But if inside your JWT token is not saying that you are, or your role is not related to the field that you requested, you're going to receive the standard response. That is another great feature that you have out of the box. And last but not least is, because you have this integration of AppSync with multiple services of AWS, when we talk about that database, you can start and use maybe RDS at the beginning and switch to Elasticsearch very quickly, because the cool thing of AppSync is that we can switch the background implementation or the intrinsic implementation that we have without showing towards the client and requesting different changes, because for the client the graph would be the same, but how those data will be resolved behind the scene, it's up to the developers that are taking care about the data source here. So as you can see, we have really a lot of opportunities for let's say managing our AppSync application. And last but not least, let's say when we talk about GraphQL, one of the benefits is that you just select the data that you need. So imagine, for instance, a mobile application that have a smaller screen request just a bunch of fields of an hypothetical catalog. Then you are in a situation that you just have that part. You can also decide what to cache in this case at the field level. And the other thing that you can do, if you are instead in a web application, maybe you want to have more data, and you can have, let's say, this query that is coming directly from the client. If you think how you would implement this granularity on REST, you have different options. You maybe want to decide to go with passing the fields that you want to have, but then in that case, use a GraphQL implementation or AppSync in this case. Or otherwise, you can create multiple APIs. Maybe you want to create APIs only for mobile, some APIs that are optimized for that, so the client is not too chatty towards the server. Or you want, let's say, another one for web. So as you can see, with GraphQL and AppSync, you have this flexibility to provide the right data for the job. Nowadays, I've seen implementation of GraphQL also with a communication API to API. And that is very interesting because it's opening up a different approach for providing access to a bunch of API. For instance, a classic example, imagine that you have, let's say you are integrating with sports data that are real time. You can, with AppSync, have a subscription directly to the client and receiving basically this information straight from to the client without the need of making request response every time. And that is something that you have out of the box in general with AppSync. So the variety of possibilities that is offering an integration inside the AWS ecosystem allows you really to leverage AppSync in a way that is simple and well integrated. Now, the next one is the Webhook. That is a very well-known pattern when you have a client that is calling a backend. It doesn't care too much about the response. It just wants to have an acknowledgement about something that happened. And in this case, for this example, we're using, again, API Gateway Lambda, but in this case, we're using RDS. Why that? Because we want to show you that sometimes you need to think about end-to-end about your solution. So imagine this scenario, for instance, that instead of RDS, you have a database that has some limitation, or even an external service, a third-party service that you need to call that has some throttling and some API limits. So in that case, what you want to do is start to limit the request that you are sending upstream, so towards the other service, database, or third-party system that it is. So you have a possibility with Lambda to use reserved concurrency. But in this example, as you can see, there is a concurrency of 5. So what it means is that this Lambda will limit the amount of let's say, requests and parallel sandbox that are running to 5. And that's great because we are solving our problem, but at the same time, it's not that great because if we find ourselves in a moment that we need to scale over because maybe you have a lot of traffic, you cannot start to throttle everything, then Lambda won't go after 5 and therefore start to return errors to API Gateway. And that's the problem when you use reserved concurrency. So what can we do differently? In the case of RDS, we are lucky because we have RDS Proxy, that is a service that allows you to basically deal with all the connection to the database and handling that despite how big is the amount of Lambda. So what it does is basically being in between RDS and the compute part. So when there is a pool available, it starts to take it and starts to let's say, connect to the database, and slowly but steady, basically, you are consuming all the different request queries and whatever you're doing with your database. But there is another option that we can do for, let's say, managing the throughput, because now we're making the example of RDS, but it cannot be only RDS that you need to handle. You need to think about maybe the third-party system was talking before. And an option that we have seen very often is the usage of Kinesis data stream in this case. Why that? Because Kinesis data stream allows you to have, you start with one shard, that is the default one, and you have a limit of the amount of, let's say, lambda that you can spin up per shard. Usually by default is one, so you have a one-to-one correlation. So you started to slowly but steady drain the stream and start to retrieve the messages from the stream, and then storing maybe in RDS. Obviously, you can integrate that letter Q to a lambda. This is a functionality that is there for a while, and every time there is a message that is a poison appeal and it doesn't, let's say, provide it's not as expected, you can save in that letter queue after certain retries from the lambda, because in this case, you can set up how many retries you want to have for a lambda. By default are free, if I remember well, and you can then store after free that letter queue, the message inside that letter queue. The problem with that is that at the moment you are going to receive a portion of the information. So what we recommend in this case is leveraging another functionality of Lambda, that is Lambda destination. So when there is on failure, you can call another Lambda that is storing inside that letter Q or SQS or whatever other tool for let's say understanding what's the problem with that specific message. Because with Lambda destination, we are capturing way more data. We understand which is the source that was passing this message. We understand how we have basically a bunch of other fields that we can leverage for debugging properly our implementation. And that is a great way and a great trick, honestly, to debugging your application when we are dealing with this situation. Obviously, Kinesis allows you to not only have one-to-one relation between shard and lambda, but you can spin up to 10 per shard, and therefore, if you have 5 shards, you can have 50 lambda that simultaneously are retrieving system, let's say, messages inside a shard. The other thing that you need to bear in mind is that, as I've said before, eventual consistency is kicking in, because you started to aggregate all this data in Kinesis, and slowly but steady you are updating, in this case, in Amazon RDS. Obviously, security is a key thing here, and therefore another option that you have with API Gateway is using Lambda Authorizer. So Lambda Authorizer is a Lambda that is running when there is a request to a specific API. You can set up maybe some API that need Lambda Authorizer, others that don't need the public. It's up to you how you want to handle that. And the cool thing is that you can create your logic for handling the authorization. The other part that is key is that you can find some examples directly in the documentation for what concern Lambda Authorizer. The other part is talking about performances. In the case of Kinesis, and again, we talk about eventual consistency once again, is that you have, by default, you are batching the request up to a certain megabyte threshold or 1 minute, but you can batch the records up to 5 minutes. And that means that basically this is a great way for optimizing your traffic, because now you start to have a larger amount of records because you are collecting every 5 minutes. That means you are calling less lambda, so the cost is lower. But again, it's something that you need to understand if it's doable based on your workload, based on your architecture characteristics. Those, for me, those 4 points that I showed at the beginning are quite fundamental. The other alternative that you can think about is, and again, as you can see, you can build the same thing in different ways. So you need to understand what are the trade-offs here in front of you. So if you, instead of using a SQL database, you can use a NoSQL database, and you have like smaller message size, you can use a combination of SQS and DynamoDB instead for scaling your webhooks, because obviously depends from the traffic pattern that you have. You might be more comfortable to scale with SQS over Kinesis. The last but not least option that you have is a fairly new addition to Lambda. That is what we call function URLs, and you can find already integrated if you're using AWS SAM or CDK or inside the console in a way that is quite interesting, because you can expose directly a Lambda. You don't have to append Amazon API gateway to expose the Lambda, but you have some limitation because the authorization that you have out of the box is based on IAM. So unless you have use a AWS user or a role available inside inside the IAM, you won't be able to call it. Or otherwise, you can create a custom authorization inside the logic of the function URL. But in this case, we provision for you the endpoint that you can call for your webhook, and then you enter basically inside your world of AWS, and therefore you can plug in this example that I made, Amazon Signal notification, so SNS for then fanning out the request to different services. So as you can see, you have for creating webhooks a variety of options, and it really depends what are your architecture characteristics, what kind of authorization you need, what kind of throughput you have. So as you can see, all the things that I said before are reflected very nicely here. Now, the next one is the big fun or the fan out pattern. And I think many of you, well, I did, for instance, at least once, I have implemented back in the days a fan out pattern, more or less like I was reasoning with containers, right? So I have a request is coming, so I need a bit of compute for sending that to SNS. SNS will send that to another piece of compute that will send inside the queue, and so on and so forth. Now, as you can see here, we evolved a lot from this way to design applications, and what we start to do is reducing the amount of compute, because the glue that we created between services is pretty great. So if you want, what you can do is directly from Amazon's API gateway, you can send the request inside SNS, and then you start to have a direct integration from API gateway to SNS. API gateway can be integrated with different services. You can even integrate API gateway with a synchronous step function if you want. That is fantastic because you can run some complex logic, but in a low-code environment. And in this case, you can even remove the Lambda that is sending the message to SQS, because in reality, you have a very well-known pattern when you talk about SNS and SQS. It is this fan out between the two. So you have multiple topics and associated the related queues, and then you start to have DL queues, and you can batch your request, and you start to have a higher durability because you have SQS. So then the consumption start to change because in this case we have way less compute. Now the consumer, that is the Lambda function at the right of this diagram, is there and start to drain in batches the different messages and do whatever logic it has to do. But we need to think about security, right? So we, first of all, another option that we have when we integrate with Amazon API Gateway is IAM Authorizer. So if, for instance, you have another IAM user available inside your account, then you can use the AWS SDK for, let's say, passing this information, and you will be able to consume and pass a message, in this case, for this workload. Now, the other thing that you can do is verify the signature that is coming from SNS, because inside the message, you have that information available. There is a specific field that will allow you to handle this additional security if you're not sure, or if you think that someone else can send the request to your consumer, in this case, the Lambda function. The other thing is, obviously, you can have not only one consumer, you can have multiple consumers, but moreover, you can even filter the messages based on specific fields. So for instance, in this case, you want to have consumer for when a status is created, when it's processed, when it's refounded, and based on the type of field that you apply, the consumer can apply the logic needed. So as you can see, we start to make quite complex logic, mainly leveraging infrastructure without needing to maintain all the logic inside the compute service, and therefore is more configuration over maintaining and testing our code. That at the end, code is a liability, so we need to be careful and wise when we want to use that. Last but not least, in the case of cost, we need to think about what we can do, and therefore compressing aggregated messages where possible allows you to achieve better cost at the end of the month. Bear in mind, batches and all the other mechanisms that you have, and embracing vendor consistency will make your workload cheaper overall. The other option that you have, if instead you want to use, let's say, Kinesis, is because we have a limitation on SNS, again, another topic we discussed before, so quotas, that is 256 kilobyte for message. We have instead in Kinesis a payload that is 1 meg, and therefore, if the case of your messages is larger than 256 kilobyte, you can switch Amazon SNS with Kinesis, and you're going to have a similar, let's say, approach. But in this case, you're going to use a bit of compute, that in this case is a Lambda, for then fanning out to multiple Kinesis data streams that are all your consumers. That will trigger other Lambdas and so on and so forth. Another one, because here we talk about streaming, let's go with streaming. So in this case, what we have is another pattern that is based on Kinesis. So imagine, for instance, that you have I don't know, click streams that are coming directly from a website, and you want to collect and store them in S3, because later on you want to analyze them and make sure to understand the patterns that the user are behaving, for instance, how they're behaving on your web application. So in this case, we have an Amazon API gateway that is triggering a Lambda, and then having Kinesis Firehose that is storing the data on Amazon S3. So first thing, we start enabling backup. That is quite common, because if you want to have the data without any transformation, you want to have exactly what was coming inside Kinesis Data Firehose, you can activate the backup, and then that will be able to be used in several ways. You can even take the backup and replay in another environment if you want, just to try that a specific service is behaving like it would behave with real traffic. But other things that you can do is leveraging the compute, so the Lambda, for instead dividing and sending this information, this clickstream, to different Kinesis. Because if we're talking about distributed system, it's very likely that you're going to have multiple teams that are interested about that, and if they are they care about the time, they can tweak the way how they're doing the shards and how to design their implementation based on what they need to achieve. Therefore, the context of every workload or part of the workload matters here, and you can easily, let's say, create different ways for sending this information and enabling teams to be more independent. The other thing that we need to think about is obviously enforced authorization, once again, Lambda authorizer, but interesting enough is also regarding PII data, for instance. So if you have like sensitive data that are flowing into Kinesis and you don't want to have them in the S3 bucket, so when they are analyzed, you can have a Lambda that is triggered when a message is coming, that is checking this information. So if there are any sensitive data, they're removing or obfuscating, and then basically inside the S3, you will have a message that is free of any personal or sensitive data. The other cool thing of working this way is that you have independence within teams, but it doesn't mean that you need to get crazy in the way how you are querying your system, because thanks to AWS Glue Crawler, you can index all these information inside the data catalog, and through Amazon Athena, you can run some queries. Now, for improving the performance of those queries, because otherwise we need to maybe load the entire JSON schema to understand how it works, you can do a transformation from JSON to Parquet, that is a format that is heavily optimized, columnar format that will allow you to, let's say, query just what is needed, and therefore it becomes faster and cheaper running into Athena. The other option that you have is for reducing the code that you need to maintain for starting to do, let's say, the integration with different contexts, with different domain from the Lambda, is, let's say, handling that part through the APIs. So in this case, you have different APIs based on the information that are coming. So you can have a different SNS topic. And in that case, the Lambda has just the duty of taking these requests and sending to a specific kinesis that will take care about the rest. So those are, let's say, some of the options that you have. And obviously, using SNS, you can also, let's say, filter the events that are coming. So some events maybe are not needed or you don't want to have, and therefore you can prevent that is, let's say, managed from the compute part that is called every time, so you can filter upfront before they arrive even to the Lambda. The last pattern that I want to show you is the Strangler pattern that is quite common in any migration, but not only from on-prem, like we were going to see, to cloud, but also from, I don't know, monolithic system to distributed one. So in this case, for instance, we have, let's say, what you can find in a corporate data center, very common. So you have a client that's calling a load balancer, and you have a bunch of server with just one database that is used. How can we migrate this workload to the cloud? And the Strangler pattern, that is a well-known pattern for slowly but steady, incrementally change your architecture, basically allows us to create a proxy in between the corporate data center in this case and the client, that in our case is API gateway. So the next step, obviously, is we start to have API gateway in front of it, and still the call will remain as they are. So they're still making exactly the same call that you're going to have. But what allows us is this decoupling between the client and the corporate data center, and we can behind the scenes start to, let's say, migrate and innovate as well. So the first step is having a VPC where you have a network load balancer that through private API of a specific application load balancer, specific balancer, will allow us to call inside the corporate data center through direct connect. That is a way for optimizing our connection between the cloud and the corporate data center. Now, why we need to build that? Because thanks to this approach, we don't care what's happening inside the data center, because the load balancer will balance based on all the, let's say, targets that are available. And therefore, it's still private, so that the communication is secure, but we can start to build upon it. The first thing that we are going to have probably centralized logs, because you want to understand what's happening on the cloud and what's happening on the corporate data center, having a clear strategy about that. In case of distributed architecture, you can have even X-ray that is, let's say, a service that will allow you to visualize what's happening inside your system, creating distributed tracing. Now we move now to have a load balancer in front of your corporate for your corporate data center servers, because now you want to have, instead of handling that part on the cloud, you start to have that on the corporate data center, so we can drain slowly but steady the server and migrating them to the cloud. Obviously, on security side, we want to have to enforce the authorization. In this case, in this example, we're using Lambda Authorizer, could be something else. But now we are in a position that we can start to take some workloads, moving to the cloud using ECS or so therefore containers or virtual machines, and slowly but steady modernize our architecture, but in an iterative way. That is, let's say, the way how we want to handle, because we reduce the risk to commit errors in production. And then when you have new functionalities, you can experiment with, let's say, serverless, for instance. The beauty of this approach is that the API gateway becomes your proxy and is allowing you the flexibility to change the implementation details, so the service to call, where the IP is resolved and where the API is called, and so on and so forth, without the need of changing everything in one go. And think about that not from a corporate data center, but on also same cloud provider, in this case AWS, where you want to move from a monolithic architecture to microservices. You can do exactly the same, because you have this flexibility of handling thanks to, in this case, an API gateway, to redirect the traffic towards the right, let's say, part of your architecture. So as we have seen, we have discussed quite a lot of, we cover a lot of ground from, let's say, different design pattern, how we need to think about serverless, and there are a lot of options out there. We also discuss about and use our well-architected pillars for, let's say, creating workloads that allows us to be reliable, cost-effective, thinking about performance, and so on and so forth. So there are several benefits that we have out of the box, and we need to leverage them properly. I want to leave you with, before we go to the Q&A part, with a bunch of useful resources, starting with Serverless Land, that is a website created by the developer advocates here in AWS that contains, in that link, a bunch of patterns where you can find there a lot of patterns based. If you want to start a serverless project very quickly and you are using Terraform, CDK, or SAM, you can select the service that you want to start, and then you have a pre-configured template that you can use and start to work on it. Then there are a bunch of other links, including the white paper of the well-architected lens on serverless, and also you have the page dedicated on serverless for well-architected. So you have a bunch of information you can take away and deep dive when you want on the architecture part. And I hope that you find this session useful. More than happy to answer your question. I hope that I will be able to answer on everything, but obviously limited about the amount of knowledge that I have. Thank you very much for coming. I hope that you enjoyed, and more than happy to take some questions.